The first thing we have to do, this is in your reinforced packet. The first thing we have to do is turn these both into improper fractions. Remember, we take the bottom, multiply it by the whole number. So 5 times 2 is what? 10 plus 4 makes, so I'm going to show some work over here. I've got 14 over my denominator. That bottom number stays the same, right? And then I have an X. And then I have an equal sign. And then I have something that's negative that we have to figure out. So again, we have to turn this into an improper fraction. So same process. We take the bottom, multiply it by the whole number. What's 4 times what? 4. Add it to the numerator. What's 4 plus 1? 5. So I have 5 over, what's our denominator? 4. Now that it looks like this, we're going to proceed. Do you remember what to do? First of all, your Chromebook should be closed. If you haven't figured that out by now, I'm going to have to tell you every day the same way. Good grief. If you need the packet, get up and grab one. Or look through your stuff. Guys, sitting there doing nothing is not wise. So I'm going to help you do the right thing. Okay. Do we remember what we have to do now? Or do we have to go back and look? This was like example 5. So if I hop back to example 5, we changed these here, and then we had to multiply each side by the reciprocal. So we looked to see what was next to x, and we flipped that fraction. So what was on the bottom went to the top, and what was on the top went to the bottom. So we're looking what's attached to the x, and we have to flip this fraction. So what is the reciprocal of 14/5? Excellent, 5/14. So if I multiply the left side by 5/14, I have to multiply the right side by 5/14, right? The reason we do that is because these cancel out to be 1, these cancel out to be 1. That leaves us with 1x, which is just x, right? And then we have an equal sign, and then negative times a positive is negative. We don't want to get rid of that. Now we're just multiplying across the top, across the bottom, because as I look across my diagonals, they don't share any common factors. We can't divide them by the same things across the diagonals or up and down. So 5 times 5 is 25. 4 times 14 is, I really don't know, 60, less than 60, because 4 times 15 would be 60, so 56.
Yeah. Can't believe I did that in my head. I'm so proud of myself.
All right, so that's your answer. You can write it here, or you can write it in the little blank they give you there.
Why did you do the word inside the box?
Because I didn't have enough room to do the work inside of the box. I don't know. I don't like being in a box. You can do the work in the box if you want to.
It makes me mad when you do the box.
The better. All right. So number 6 is just like number 10. So again, we're looking to the side where our variable is and multiplying both sides by what? No. No, still no.
What am I doing? 0, 1, 0.
No.
What are we trying to find with the
All right, over up here, we looked at the side where the variable is, right? And we multiplied it by this reciprocal. Careful. Great, horrible timing. No, sit down. Guys, I'm not going to be teaching forever. If you need something, you can take care of business in a little bit. Can we stop throwing the pencils though? That'd be great. All right. So up here, we multiplied by the reciprocal of what was attached to the variable. So down here, we're going to multiply by the reciprocal of this. What's the reciprocal of 3/5?
5/3.
Excellent. Yep.
It sounds good.
So if we multiply this side by 5/3, what do I have to do to the right?
Also.
Multiply it by 5/3. So if you need to write it out a little bit more neatly, you might write it as 5/3 times -6/1, right? You can do this one of two ways. You can multiply across the top, across the bottom, and then simplify. Or you might notice you can take out a factor of 3 across this diagonal. So 5 times -2 is -10. Or you might have had -30 divided by 3, right? If you multiplied across the top and then the bottom. And -30 divided by 3 is also -10. So one way or the other, you got to get -10. So we have -10 here on the left. We have an equal sign. And then what's left on the right? These all cancel out, so we're left with y. Done. Okay. All right, number 13 is like number 11. So hopefully you did this. If we're multiplying something by b, to undo that multiplication, we have to divide both sides by the same thing. Handy dandy calculator. So you have 6 divided by 0.2, 30. Positive or negative though? -30 is equal to, these cancel out and become 1. 1b we write as b.
My B looks like a spoon and I'm not like.
All right. So what do I do for number 14 here? Oh, the exact same thing. What am I dividing both sides by? -0.8. How do we read that decimal? Oh, we don't say 8/10. Perfect. So remember, we say the number and then the place it's in. That helps us when we have to change it to a fraction for sure. All right, so if I divide the left by -8/10, I have to divide the right by -8/10. That was horrible. So I would say n, right? 1n is equal to, good, 2.8. That shouldn't be 4. Divided by 4 should be 0.7. Oh, what did I do?
Out loud at the same time.
Okay, I'm getting confused. 2.8 divided by 0.8. This is 3.5, sorry. -3.5.
I was really close. If I wasn't doing that. Terrible. It's okay.
4 would have been 3.2 divided by. All right. What's being done to C? They're subtracting 5.3 from it. So how do I undo subtracting 5.3?
Add 5.3.
Excellent. We have to undo subtraction with division. So we have C on the left, right? -5.3 plus 5.3 is 0. That's what we wanted to happen, right? We wanted to get rid of that constant. So 0 is equal to the difference of this. So 6.4 minus that is 1.1. You can use a calculator. Your bigger number is negative, so your answer is negative.
I got 11.7. I think I did it wrong there.
You added.
Oh,
Your signs are different.
Oh.
So if you've got a negative and a positive, you have to find the difference. You got to pay attention to your sign and those integer rules.
I'm getting that like weird little jag right here from holding your pencil.
No. All right. So this next one, remember, we have to find common denominators. Can 3 go into 6?
Yeah.
So let's change it to 6. What do I have to multiply the 3 by to make 6? 2. So that's what I have to do to the top. So I have negative 2 over 6 is equal to negative 5 over 6 plus W. Looking at the side with our variable, how do I get rid of negative 5, 6? Nope, we're not multiplying because it's not attached. Well, right now it's essentially being subtracted to, right? Remember our additive inverse? We have to add the opposite. So what's the opposite of negative 5, 6? Positive 5, 6. So if I added 5, 6 to negative 5, 6, would that be 0? Yes, and that's what we want to happen. We want this to go hasta la bye-bye. That's 0. So we're left with a W on the right. If I added 5, 6 to the right, what do I have to do to the left?
Add 5, 6.
I have to add 5, 6 to keep it equal. Can you do that?
Mhm.
What's negative 2, 6 plus 5, 6?
Negative 3.
It's not negative.
Positive 3.
I don't know.
Just 3.
What am I doing?
The top, the numerator is going to be 3.
Yes.
What's
Oh,
the
yeah.
denominator
3,
still?
6.
It
So
stays
all
the
the
same. So 3, 6. What if I told you this was wrong?
I believe you.
What would you do?
I tried.
I probably just believe you.
Okay, so think about 3, 6. How else should I be writing 3, 6? 1/2. Yep, you should be dividing both top and bottom by 3. So W is really equal to 1/2. I don't need to go searching through my drawers in my cupboards looking for a cup that's 3/6 of a cup, right? I'll be really confused and searching forever. Nothing's gonna say 3/6.
I'd cry.
All right, same thing here, except we don't have to change denominators or anything. We've got handy dandy calculators. How do I get rid of a positive 7 1/10? I just gotta take it away, right? So I'm gonna say minus 7 1/10. If I do that on the left side of my equal sign, I have to do that on the right side of my equal sign. So on the left, coming down this column, I have a N. This became 0. And I have an equal sign that needs to come down, bless you. And then I'm going to take these away. So 6 minus 1 is 5. Bring down your decimal. 8 minus 7 is 1. That's it.
Oh.
So hopefully you got those in your page. There were 2 more, I think. Yes. This table, so this was like number 16 on the work you did yesterday. So the table shows the balance of Rob's checking account at the end of the day. It looks like there's an unknown.
That's not great.
So this is $95.50 less than the amount he had at the beginning of the day. So if we want to find what he had at the beginning of the day, we're going to take whatever that was at the beginning of the day, B, and if we want to know $9.50 less than B, what would we do? Subtract $95.50. They're telling us that this amount, this balance is another word for equals. So they're saying that this is equal to that, so we can set it equal to $4.50.
What is that?
So which one of these looks like
Oh, it's.
they flipped them around?
And last question, what is it?
The last one? Look at the last one. It says 95.50 minus where they started. Is that what we did?
No.
No.
Wait, the seven.
Yes, subtraction is not commutative. You know what that means? You can't
undo it.
switch it. Like, if I'm trying to figure out 5 years less than my age, I would take my age minus 5 years. I couldn't say 5 minus 38, I would be negative years old. That doesn't make sense, right?
I don't know, you could be. I have a
Yeah.
question. Why do we use letters? Because we're using our actual real life.
Yeah, because like we're trying to figure out what the balance was.
Yeah, we're just trying to graduate high school. I don't think you're gonna use this after that.
The letter is a placeholder to figure out an unknown. There's going to be lots of unknowns in your life, trust me. Especially for you. All right, lots of unknowns. What was Rob's account balance at the beginning of the day? So how do I solve for B?
You take a calculator.
You can take a calculator for sure. But how do I get B by itself? How do I get rid of this negative 9550? Add it. So if I add 9550, isn't this side going to be 0? Yes.
My hand hurts, so I gotta get some different.
So if you're like, if you're wondering how much money you spent that day and all you know is your balance, you can figure it out. So B is equal to $99? No, $100.
Oh, I drew a line through everything.
Because 50 cents and 50 cents raises this up another one. 4 plus 5 is 9 plus that one makes 10.
I have to learn how to use the not web part of my hand to write.
So what was Rob's account balance at the beginning of the day? 100. Did you guys do that yesterday? Did you figure that out?
Yeah.
It's a little tricky. This last one is like number 17. So a diver is at a certain depth in the ocean. So this is what we don't know. After ascending, do you know what it means to ascend?
Yeah.
Go up. The only reason I know what it means to ascend is because I know what it means to descend, right? I don't like decrease, descend. Ascending means nothing to me without descending. I don't know. So we're gonna go up. So after going up, so we're really adding 10 3/4 feet. The diver is now at a depth of something. So we have something, they're gonna say this depth plus, after going up 10 3/4 feet, they're now at a depth of negative. Oh man, we've got fractions, we've got integers. Lord have mercy. Negative 56 1/2. Whew. Okay. Just looking at this, it's like, ugh, right? But which one of these looks like it? Not this one, not this one, the third one? Okay. So now we've got to solve it. How do I get rid of 10 3/4? Is it attached? Is it touching it? No. This 10 3/4, what is the operation it's being done to D with? They're adding it. So what's the opposite of adding? Subtracting. So we either have to take the opposite of it, knowing it's not attached, right? Or we have to do the opposite of like the inverse operation. So if we know it's being added, we have to subtract it. I know you don't want to subtract it, right? But we have to. And actually subtracting it makes it a little bit nicer because we have D is equal to, are the signs the same or different? Same. So Taylor, when the signs are the same, we find the what? What do I always tell you? When our signs are the same, we find the sum. So the sum means I'm adding them up. Adding them should be a little bit easier. But what do I have to do with my fractions in order to add them? Find a common denominator. Can I use 4? How do I change this to make it a 4? Multiply it by 2. So that's what I have to do to the top. Ugh, you got it. So if I'm adding these, I have 2/4 and 3/4. So I really have 5/4. If I'm going to kind of come up here for a second, because if I have 5/4, That's improper. So I gotta take a whole out. If I take a whole out, how many pieces am I taking? How good. This tells me how many pieces make a whole. So if I take out 4 pieces, I'm gonna put it under the ones, and what am I left with? How many pieces am I left with? 1/4. Good. That was a lot. Especially if you don't like fractions, right? We have to remember lots of pieces there. So now we're still finding the sum. We've got 6, 7, 7 ones, and how many tens? 6.
This is getting messy.
Both of our signs were negative, so our answer is going to be negative. So what was the diver's initial depth? Good. Now, does it make sense? So a diver is at negative 67 1/4 feet. After ascending 10 3/4 feet, does that seem reasonable? Yes. The negative is going to be less as you go upwards, right? Or to the right if you're thinking about the number line. So it should make sense. Don't forget that common sense. All right. Assuming you've already done what you're supposed to do, you should be through 23, but if not, you have 20 through 27. So you're finishing these up. Again, if you followed along and done what you have been supposed to be doing, you shouldn't have too many problems today. So you've got 24, 25, 26, and 27. Again, a whole whopping 4 problems. So go for those. Do them. Then don't forget about Alex, right? You still need 5 topics this week. You've got 25 minutes. Yeah, or you could, do the 4 problems right now and I can help you. How is that helpful for you, though? You have to be good at math. Good. I love that because there's
Summer packets, like 3 of them in one day.
well, there's
Yeah.
there's no better way to get to know some information than by learning it multiple ways. Right? So if you're sitting there like, then A, you might need to put forth a little bit of effort, or B, you might need to look at it a different way. Or C, you just need some individual help.
We're supposed to be doing this one.
That's why we're here. All right. So finish up 6-1 reinforce. That puts us at some practicing of 1-step equations tomorrow. Yeah, I think I got a fun pixel art. Yeah. Yes. Oh. Elijah.